Hello test takers, welcome back to Exam Prep Solutions. We have another practice problem. Today we're going to be going over some fluid mechanics with the energy equation here. We have a free guide, the 5 steps to solving any FE exam problem. You can find that in the description box down below. It's 100% free, just tell us where to send it. Okay, let's get into this problem here. I have the FE exam excerpt here. Make sure to pull up your FE handbook. Try and find this section and attempt to do this problem before I even solve it. And now that you've had a chance, we're going to get into this one. So with a 10-foot elevation difference between the reservoir and this pipe exit, determine the exit flow rate of the water. The diameter of the pipe is 1.5 feet. And so this is a common problem. You're going to want to think energy equation here. And you can use Bernoulli or the standard energy equation in this case. We're not going to account for head loss in this problem. And so we're really going to want to use these equations here. And so we're going to want to select 2 locations that we want to conduct this problem from. The first location is the top of the reservoir here where it's open, and the second one is at the exit where the water is exiting the pipe. Those are the 2 locations we're looking into for location 1 and 2. And so let's start the problem here. If we look at pressure 1 over gamma, well, it's open to the atmosphere here, so we're going to have a pressure of 0 in this case, plus Z1. And we know we have a 10-foot elevation difference, so we're going to have 10 feet there, plus V1 squared over 2G. The water isn't moving, it's static at the top there. So we have also a velocity of 0. So that's the left side of this equation. Now for the right side, we have P2 over gamma. Now also where the water is exiting, that's also open to the atmosphere, so the pressure is 0 there. Z2 would be 0 because we've gone all the way down 10 feet. We're considering this to be our datum, this to be the top at 10 feet. And then now we have V2 squared over 2G. Because the water is exiting, it actually does have movement there over 2G. So this is the setup for our problem. 10 equals V squared over 2G. And with the units we're using, G is 32.2. So we're going to multiply that to the other side there. So 644 equals V squared. So to find the velocity, we're just going to take the square root. And so that's going to equal 25.3772. And so you may think, all right, I found my answer, I'm done. Not quite. We want to know the flow rate, which is in cubic feet per second. And so we do know this equation here, the continuity equation, Q equals V times A. So we can find Q by multiplying V times A. 25.4, I'm going to round. And what's the area here? Well, we have a round pipe and a diameter of 1.5 feet. And so we know that pi times the diameter squared over 4 is going to equal our total area. We multiply that by the velocity and we get an answer of 44.86, so 45. So it looks like answer D in this case. So that's how we solved this equation here. First, we found what we needed for the energy equation, labeled our points 1 and 2, broke down the individual elements, solved for the velocity, then used the pipe diameter to then solve and find that flow rate, which was what we needed here. And so the answer is D. Let me know how you solve this problem. If you have any questions, leave it in a comment down below. If you have any requests for sample problems, you can also leave that in a comment down below. Like this video, subscribe to see more problems like this, and we'll see you guys in the next video.